hey, memorize this. Okay, so let's see how this was developed. And I'm sure it will make sense to you. Okay, so let's say this is a function, f of x. And let's say this is an interval, 1 unit interval, a comma b, like 2 comma 3, 5 comma 6, 10 comma 11, 1 unit, or smaller. That doesn't have to be 1 unit, but we prefer it to be 1 unit to be exact. Okay, so this is a solution. We know that f of c is 0. In other words, let me, in parallel, explain with an example. So I'm going to pick an example. We are on page 342. And I want us to look at the function, the problem 17. It's in red. Let's see, why is it in red? Cosine x equals x plus 1. So I want to solve this equation. I have no idea algebraically how to solve this. There is no method, algebraic method. But you can say, what does this have to do with that? Oh, very simple. Of course, I will have to create the function 3 cosine x minus 1 equals 0, and this is my f of x. So I'm solving basically the equation. I can say this equals that, but it's easier and better to move everything to one side and have this function set equal to 0. It's just exactly the same situation. So if I graph this function, assuming it has a solution between a and b, and this is the solution. Algebraically, I have no method. So I will have to start at one of the endpoints. So I'm going to say start x0, let's say, equals little b. What does that mean? It means that I consider the initial value for the method. The method is a sequential method. Step 1, step 2, step 3, step 4. So this is my first step. I choose to start at the end of the interval on the right-hand side of the solution. That's my choice. Can you start here? Of course. Okay, so this is my initial value. So this is my x0, or x sub naught, or x naught. I'm going to draw a vertical line, and I'm going to create a point. Let's call it A. And I would like you to give me the coordinates of A.
X O B.
Comma. Excellent. F of x 0. Very good. Do we all agree with the coordinates of point A? x0, comma, f of x0. We agree? Yes? Perfect. I am going to draw a tangent through this point. It will hit the graph in this point. It will hit the x-axis at this point. This is the C here, and this point is going to be called B. Can anyone give us the coordinates of B? The answer is not, but you can give me one of them. You cannot give me the x coordinate. You don't have it. I don't have it. But you can give me the y coordinate, which is? Of course, it's on the x-axis. Excellent. Very good. We don't know the x coordinate of B. I'm going to call it x1. x1, first iteration of the method. A question before we find that. Do you think now that x1 is a better approximation of little c than x0 was? It's much closer to c than my initial value was. Agreed? Let's try to find it. So this line, the tangent, has 2 points. The point A, x0 comma f of x0, and has point B, which is x1 comma 0. I would like you to give me the slope of the tangent line at A. Forget about the 2 points for a moment. I just want you to look at that and say, oh, the slope of the tangent at A is blah. And I will write it, of course. Do not involve the points. I don't care about that. What is the slope at A, of the tangent line at A? Okay, you want to do that first, fine. So then you will say 0 minus f of 0, f of x0, over x1 minus x0. I agree. I want it now in a different way, not with these. This is perfect. I would have asked you this, the same thing next, so you gave it to me. But there is one other way. That's why we studied all these chapters in calculus. And we know exactly what the slope of this line is. Exactly, f prime of x0. Yes, I want that, right? F prime of x0, of course. This must be it. It's the slope of the tangent line to the graph of the function at A, which has x0 as its x-coordinate. Excellent. Okay, I got an equation. I'm very proud of myself. And now please tell me, what do you think I'm going to solve for? What is the unknown? Which one? I have it. I chose it. That is very well known. F of x is well known. I have the function. I have the function. 3 cosine x minus 1. So what am I after?
x1.
Exactly, because it's a better approximation of the real solution than x0 was. I want to solve this for x1 indeed. Excellent. x0 is known. I pick it. I pick x0. So it's very well known. You pick your x0 that you want. So it's very well known. What I'm interested in is in getting a better approximation of the solution than x0 was. Yes?
So does that mean x0 can be
Anything, but it has to be by the intermediate value theorem. You have to choose the interval where the solution is, and you will start at either end. We're going to work on this problem in a minute. Good. So can anyone tell us how to solve this equation for x1? x1 is what we are after. So negative f of x0 over x1 minus x0 equals f prime of x0. This is your hint, over 1. What am I telling you to do by putting it over 1? Let's cross multiply and find x1. Excellent. Well done. So negative f of x0 equals x1 f prime of x0 minus x0 f prime of x0. I have to distribute. So 1 times negative f of x0 is on the left. F prime of x0 times x1 is here. F prime of x0 times x0 is here. We isolate x1 by moving this term to the other side. So x0 f prime of x0 minus f of x0 equals x1 f prime of x0. I am after x1. And you tell me what I need to do.
Divide by f prime.
Yes, but I will divide term by term, not just write a fraction line and write. Okay, when I divide the first term by f prime of x0, what do I get? What is left from here?
x0.
Excellent. Minus f of x0 over f prime of x0. This is the first iteration, which is a better approximation than x0. I'm back to my graph. Very difficult to show because I'm already so close. I will repeat the process. I will draw a vertical line through B. It will hit the graph in point D. I will draw a tangent at that point, and I will get, of course, x2, and continue forever, for as long as I want. Can anyone come up with x2, and then x3, and then dot, 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 xn plus 1? Think about it, and whatever you tell me, I'll write it. Of course, x1 minus, very good, over, very good. Okay, x3,
X2,
very good, minus,
F X2, over F prime X2,
good. Now the last one.
Xn plus 1.
This is Newton's method. This is Newton's method. There are two problems, though, potential problems. Here's one. I'm going to write it down. I will be in deep trouble if I choose x0. That makes f prime. Yeah. So I have to be very careful. I cannot just simply pick. I have to make sure that what I pick as x0 does not make f prime 0, because I'm not going to get to the second iteration. I'm not going to pass the first one. I'm not going to be able to calculate it, because 0 in the denominator means undefined. So that's one problem. So you have to be careful with that. Second problem is, if I pick x0 to determine c, and there is a max or min of the function between these two, the method will not converge. I will stay here because there is a minimum or a maximum between, and I will never get it. So be very careful, two situations. What you pick does not make f prime 0. And the second situation, which it's rare, but make sure that there is no max or min between the actual solution that you are trying to find and the initial value you pick. Okay, so we are back to our example now. Here's a, yes, please.
On the example, like, when you boxed your answer right there, I don't understand how you got that
From here?
Yeah.
Okay, so I have, in order to solve for x1, I have to divide by this number, whatever it is. So when I divide the first quantity by this number, it goes away, and I only have x0. And then I copy minus. Here I cannot do anything. I have to have f of x0 at the top and f prime of x0 at the bottom.
Okay.
But the first one can simplify.
Okay.
And it repeats. If we go redo for x2, we're going to get the same answer. Is this better? Okay. So we are using Newton's method for something like this that you would have never ever dreamt of being able to. Which page am I on? Is it, am I on 11? Yes. Okay, so here's our problem. 17, I didn't copy 342. So we have 3 cosine x equals x plus 1. I only need one function. I have to set it equal to 0. 3 cosine x minus 1 is 0. This is my function f of x. So I'm solving the equation f of x equals 0. I have no algebraic method to do that. I will immediately find f prime, which is negative 3 sine x minus 1. I will write Newton's method as x. I'm going to write x as a uppercase, like a function. x0 minus the function 3 cosine x minus 1 over the derivative, negative 3 sine x minus 1. And of course, this will always be x0 as the beginning. The first iteration will be calculated. But I want to put it in as a function. Also, we need a starting point. Since the function is continuous everywhere, I have to find, using the intermediate value theorem, I have to find an interval where the function changes sign. So I have to put that in the graphing calculator. So let's put it in. So in y equals, clear if you have anything else. So I have 3 cosine x. 3 cosine x. Let me check my mode. Radians, perfect. Okay, 3 cosine x minus x minus 1. Minus x minus 1. And I already see it. I have a cheat sheet here for the software, and I see somewhere between 1 and 2. So I'm going to go to second and table, and I'm going to plug in 1. I'm going to plug in 2. I see the function. Okay, it's frozen. Yes, Ricky? Yes.
I got it.
Cosine x minus x minus 1. Let me look at the mode. Okay, maybe you're correct, and I have to look again and how you entered it. Well, let me look again at my graph, at my function. Okay, it's frozen.
Oh no.
I don't know why. I don't know why. I have no idea.
Maybe cancel
I have no idea why it's frozen. I'm going to try and it won't let me even close it. Okay, so can you, with your calculus, can you tell me what is when x is 2?
Negative 4.248.
Are you in radians? So then I have, there is some sort of error in there. Okay. So in y equals, so I have 3 cosine x. I'm checking mode, radians, yes. So in y equals, let's forget about that. I don't know why it's frozen. 3 cosine x minus x minus 1. Minus x minus 1. So then I go to second and table. And I want 1 and I want 2. Okay. So I want 0. And I want 1. Okay. So between 0, which is 2, and 1, which is negative, I'm fine. I can pick either one. So you would like to start at 2, or would you like to start at 1? It doesn't matter. There is a solution for sure between 0 and 1. We can start with x0 to be 1 or x0 to be 2. 1 or 0, sorry. Right? So at 0 is positive, at 1 is negative. Which one would you like to start with? We have to pick either 0 or 1. Okay, as long as, so we want to pick 1? Okay, perfect. As long as this is not 0 and it's not going to be 0. Okay, here's our next step. Go back to y equals. I'm going to try and see if this is doing, no, it's frozen. Okay, so go back to y equals. And now I would like you to insert x minus parentheses. I'm inserting this function, of course. So I have x minus, I already have this because I entered it before. Put the right parenthesis and divide by, put this, negative 3 sine x and minus 1. Sine x in parentheses and then minus 1 and close the parenthesis. And then I would like to go to variables. Click on variables. Yes? Yes, so you have x minus in parentheses. Okay, so x minus in parentheses 3 cosine x, right? Minus x minus 1, close the parentheses, and we divide by in parentheses negative, it was 3, right? Sine x, close the parentheses, minus 1, and close the parentheses. Then we go to variables right here. So we recall, so after variables, go to y variables, and we are recalling a function. Here's the function, and we are recalling function 1. Press enter. I didn't mean to do it there, sorry. We have to get out of this window first. Second and quit, get out of that window, and then go to variables, and y variable, and the function, and it's y1. And you told me that we wanted to start at 1. So y1, this entire function when x is 1 everywhere. What do I get? What is this? What does it represent? What does this represent? Exactly the first iteration. 0.89243795. Is this good enough? No, of course not. So let's go back now.
Wait, I have a question.
Yes?
Why is it x0? I mean, why is it x1 instead of x0?
We already plugged in x0. X0 is 1. So in this function that we created, we plugged in our initial value. So the next step is x1.
Okay.
When we plug in the number that we just determined, in a minute I'll show you, we will get x2. When we plug in the next one we'll get x3. Better? Yes, Brayden?
I got a different number for the y.
Did anyone else get this number?
Yeah.
Because you put parentheses around x minus 1 instead of parentheses for sine. So sine is only applied to x and then minus 1 outside. Is that clear? Okay, so now here's what we do next. Please put in second and entry. And go back on top of 1 and put it second and previous answer. So now the next step is the function will be evaluated at this number. And you don't have to plug it in, you don't have to truncate it, you don't have to touch it. What is this? This is x2. Okay, I repeat. It's bringing in, it's putting in the next step, it's putting in the previous value. What is this? You can go on forever, depending on how many digits you want, accuracy. So 8894, 8894, 8894, I'm happy with 4 digits. Then I would say, as you see, 4 digits, 6 digits. Okay, so the first 5 repeat. So if you already say, oh, 5-digit accuracy, I'm fine with it. And then you will stop. So our x1, our x2 was 0.889472, x3 0.889470. If you're fine with 5 digits accuracy, 5 decimal digits accuracy, you can stop. The method converged in 2 steps. But this was possible because of calculus. We didn't know, there was no algebraic method for this. No one can solve that equation by hand. It's either calculus or calculators. This is Newton's method. Yes, Brayden?
So x1,